Assalamualaikum and hi everyone. Today me and my team will present about the topic that is application of differentiation. But before we start the presentation, let me show you introduction of application of differentiation. Okay, the introduction is to determine the rate of change of a quantity with respect to another changing quantity. To determine maximum, minimum certain points of a function. To determine the quantity and conversity of a function. Okay, next there is 7 steps that we are going to use on this topic to solve the question. Step 1, differentiate the function given y equal fx. Step 2, find the value of x when dy over dx equals 0. Step 3, substitute the value of x in fx. Step 4, write the coordinate xy of any point. Step 5, use the second derivative d power of 2y over dx power of 2 to find the maximum, minimum or inflection point. Step 6, write the coordinate xy of maximum, minimum or inflection point. And the last step, step 7, sketch the graph. But for step 7, it depends on the question, because some question they didn't ask for the graph, so it will end at step 6.
So thank you Karen for the explanation of introduction of application of differentiation. So my question is, find all of maximum and minimum and sketch the graph. So question number 1 is f in bracket x equal x power of 2 minus 5x plus 6. So in application of differentiation, we have 7 steps. So first step, we must differentiate. So x power of 2 minus 5x plus 6, we differentiate, we get 2x minus 5. So let's go to step 2. Step 2, we must equal to 0. So f prime in bracket x equal 0. So 2x minus 5 equals 0. We get x equal 5 over 2. So we go to step 3. Step 3, we must substitute x equal 5 over 2. So f in bracket x equal x over power of 2 minus 5x plus 6. We substitute x equal 5 over 2. We get in bracket 5 over 2 power of 2 minus 5 in bracket 5 over 2 plus 6. So we get 35 over 4 minus 35 over 2 plus 6. Negative 35 over 2, we must make it same like 35 over 4. So we get 35 over 4 minus 50 over 4 plus 6. So we calculate, get 35 over 4 plus 6. So we simplify, we get minus 6 over 1 over 4 plus 6. So we calculate, we get minus 1 over 4. So we go to step 4. So step 4, we have to write the coordinate of xy of turning point. So So the stationary point is at 5 over 2 and minus 1 over 4. So we go to step 5. Step 5 we use second derivative. The formula is d power of 2y over dx power of 2. So we calculate, we get 2. So step 6, we have to write the coordinate xy, maximum and minimum points. So 5 power over 2 and minus 1 over 4 is a minimum point. So step 7, we have to write the graph. So we take from step 6, 5 over 2, we convert to decimal number, we get 2.5. So because of this, we take 2 and 3. Firstly, we use 2, f prime x equal to. So we take from this step 1, 2 in bracket 2 minus 5, we get minus 1. So the graph must to the left, so like this. So third, we have f prime x equal 3. So same again, we use that one, 2 in bracket 3 minus 5, we get 1. So the graph must right. So that's all from me.
Thank you, Fahmi, for your explanation in question 1. Okay, I will continue with the next question. Firstly, this question didn't use graph. So, this question is fx equal x power of 2 in bracket 2 minus 4x. In the step 1, x2 multiply 2 minus 4x. So we get 2x power of 2 minus 4x power of 3. dy dx differentiate from 2x power of 2 minus 4x power of 3, we get 4x minus 12x power of 2. So 12x power of 2 we bring to the in front and 4x we bring to the behind. In step 2, minus 12x power of 2 plus 4x equals 0. x1 we get 0, x2 we get 1 over 3. In this step 3, y equal x2 multiply with 2 minus 4x. Substitute x equals 0, y equal 0 power of 2 multiply with 2 minus 4 in bracket 0 and we get 0. So lastly, y equal in bracket 1 over 3 power of 2 in bracket 2 minus 4 in bracket 1 over 3 and lastly we get 2 over 27. Okay, so we go to the step 4. We have to find the coordinate x and y. So the stationary are 2 over 27, 0 and 1 over 3, 0. We go to the step 5. We have to find the second derivative and we use the formula d power of 2y over dx power of 2 equal minus 24x plus 4. And then minus 2x multiply 0 plus 4 equal 4. In value we get minimum. And then minus 2x multiply 1 over 3 plus 4 equal minus 4. In value we get maximum. So we go to the step 6 or last step. We have to find the coordinate xy, minimum point and maximum point. So 0, 0 is minimum point and in bracket 2/27 and 1/3 is maximum point. Thank you.
Thank you, Haris, for the explanation. Assalamualaikum warahmatullahi wabarakatuh, and I will discuss about my question. So the question is given is y equal to 4s power of 3 minus 6s power of 2 minus 72s minus 20. So the first step is we have to do a differentiate by using a dy over dx. So how to use the differentiate method is power of x, we have to bring in front of the number and we have to multiply it, and the power of s we have to minus 1. So for the question is, you can see 4 times 3 and we got 12, and s2 is 3 we minus 1, so that's why we got 12s power of 2. Same goes back is minus 12 and minus 17. So move to second step is equal to 0. For dy over ds is equal to 0. So dy over ds is just now for step 1 that we got the answer. So we just have to write down back and equal to 0. This will equal to 0. And after we got this 12s power of 2 minus 12s and minus 72, we have to do a quotient number by using a calculator. So we just have to set the number in calculator, and we gonna got x1's answer is 3, x2 is minus 2. So for the step 3 is we're gonna substitute s, which is that we got from step 2 is s1 equal to 3 and s2 equal to minus 2. So and then first step is we're gonna write down the question back again. So write down, and then all of these s we're gonna replace it with the s that we got from step 2, which is 3n minus 2. Then we just replace the s, and for the first s we're gonna get 100 minus 182. So for the second s then we got 68. So we move to step 4, which is we have to find xy coordinates. So after we got all the answer, so we just have to write down the coordinates that we got from step 2 and step 3. So essentially are negative 2, 68 and 3 minus 182. So move to step 5 is a second derivative. So the formulas of second derivative is power of 2y over dx power of 2. So we have to use the same method with step 1, which is that differentiate, and by using the answer that we got from step 1. So the answer that we got, just we have to write down back, and we have to do the same method, which is we have to bring the power in front and power of s minus 1. And then we got the answer is this. And then after we got the answer is, we have to substitute again of s, which is that we got from step 3, that we got 3 and minus 2. Just have to replace the s, and then we just insert to calculator, and we got the answer of negative 16 and 16. Negative 16 for negative 2s and 16 for 3s. So there are two points that we got here, which is a negative point and positive point, which is negative is maximum point and positive is a minimum point. So move to step 6 is we have to coordinate a maximum and minimum point. So how do we put the answer is, so maximum point is that we got just now is negative 2 at 68, and minimum point is 3 minus 182. Okay, so for the last step is a sketch the graph. So this is the maximum point and this is the minimum point. So which is maximum point minus 268 and
minimum point is 3 minus 182. So before we do the graph, we have to do like this, and which is x we will replace with 0. So this we got from the question that we're gonna write down. Okay, and just replace the x with 0, and we got the negative 30. And for the y is equal to the question. So jadi we just have to replace a 0 and just calculate. You see the equation calculator, and we're gonna get the answer is S1 is 5.1692 and S2 is minus 3.3834. And then after we got the answer, and the curve gonna be like this. We just have to plot the maximum point and minimum point, and the graph will be like 5 and minus 3. So that's all from me.
Okay, conclusion about the topic. The derivative of a function can be used to find the slope of its graph at any given point. Higher order derivatives can be used to analyze the curvature of a function graph. Applications of derivatives include optimization, relate grid problems, and finding critical points, inflection points, and continuity. Thank you.
Thanks for watching. Hope you guys can learn something from our video. Wish it to all of you. Selamat berpuasa semua.